Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Free radical halogenation of butane, CH3-CH2-CH2-CH3 with Br2 under HV, light, involves abstraction of a hydrogen atom to generate a radical intermediate, followed by bromine capture. Moving on to the next step. Identify the sites of bromination. Butane has two types of hydrogens, primary, C1 and C4-6H each, and secondary, C2 and C3-4H each. Bromine radical is highly selective and preferentially abstracts secondary hydrogens. Thus, bromination predominantly occurs at C2 or equivalently C3 by symmetry, giving to bromobutane as the major product. Moving on to the next step. Analyze the stereochemistry of the major product. To bromobutane, CH3-CH2-CH2 has one chiral center at C2. Free radical bromination is a non-stereospecific process. The planar radical intermediate at C2 can be attacked by Br2 from either phase with equal probability. And for the final step. Since attack occurs equally from both faces of the planar radical, the R and S enantiomers of 2-bromobutane are produced in equal amounts, giving a racemic mixture, 50% R plus 50% S. B. Meso. A meso compound requires at least two chiral centers with internal symmetry. 2-bromobutane has only one chiral center, so meso is not applicable. C. Diastereomers. Diastereomers require at least two stereocenters with different configurations, not applicable here. D. Constitutional isomers. These would differ in connectivity, not stereochemistry, not the situation here since the major product is specifically 2-bromobutane. Therefore, the correct answer is A. Therefore, the correct answer is option A.